So previously, in the previous session, we have discussed about subnet mask and the broadcast ID and network ID, various other things we discussed, some basics we discussed. So today, we'll discuss about private versus public IP allowed ranges. So what are the allowed ranges in private and public IP? So uh, the Assigned Numbers Authority, the Internet Assigned Numbers Authority, IANA, is actually this is the organization which actually created these ranges, actually IP addresses ranges they have created. So they also established certain blocks of IPv4 addresses for the use of private, that is for LAN, and public internet addresses. Okay, mostly private IP address we use inside our organization, so we call local area network. Okay, and public IP address we use mostly for internet addresses. Okay, so private IP can only allow certain values. The range will be the private IP. So from 10.0.0.2 10.255.255.255. Okay, this is a range used in big networks. That means here /8, it is called CIDR. What is that? We will see in a moment. So /8 means what? Out of 32 bits, 8 bits are reserved for network ID. Remaining 24 bits can be used for host ID, right? So it is used in big R networks. So this range has been reserved for private IP. And 172.16.0.0 to 172.31.255.255 is reserved for AWS. It is reserved for AWS range. So whenever you create any instance on the cloud, on the AWS cloud, the IP address whatever you get for that server will always be inside this range only. So you observe next time whenever you create an instance, the range falls in this range only. And remaining this one 192.168.0.0 to 192.168.255.255, this is a range we mostly see, this range in our homes. In our home, whenever you even you right now test with IP config, your IP address, private IP address will come in this range only. You should understand that. And all the rest of the IP on the internet are public IP. So other than these three ranges, all remaining whatever they are, all comes under public IP, and public IP are used for internet purpose only. So that is about private and public IPs. Now let's come to the main topic, that is virtual private cloud. So what is that? We discussed already, but again we discuss. We go to definitions and we try to understand a little bit more in depth. So what is virtual private cloud? A virtual private cloud is a virtual network that closely resembles a traditional networking that was operated on premises in their own data centers, with the benefits of using the scalable infrastructure of AWS. That means what? So for Infosys, Wipro, TCS, Capgemini, many companies are there, right? Old companies, they have their own data centers, right? Same like that, virtual private cloud is also like a virtual data center. It closely resembles a traditional networking that was operated on premises in their own data center. But those data centers the data centers which are physical data centers are on premises data centers, which cannot be extended quickly, right? If they want to add 50-30 servers extra immediately, they can do it. But in VPC, it can be extended scalable with the benefits of using the scalable infrastructure of AWS. So VPC is same like our on-premises data center with more capabilities. That means you can increase, scale up and scale down whenever you want on your virtual private cloud. Or in short, VPC is a virtual network or data center inside the AWS for one client. So for every client, they can have their own data center on the cloud. So that data center we call it as virtual private cloud. That we should understand. Okay. So why use a virtual private cloud? Enhanced security. A VPC allows you to secure your virtual networking environment, including your IP addresses, subnets, network gateways. For instance, you can securely isolate a database in a private facing subnet that is not connected to the internet. What is subnet? We will come to know in few minutes. But try to understand. You can, if suppose you have some databases which are installed in a server, and those servers you can move into a private facing subnet. When a subnet is private, then the servers cannot be accessible. The database which are running in those servers cannot be accessible by the end users. So nobody can access them using the internet. So such kind of security you can provide by using virtual private cloud. On demand flexibility, you can design the cloud architecture that best serves your company's needs. For example, you can set up your VPC for contractors to use individual direct connections that are not routed through your internal network. For example, if you take a company called Verizon, okay, in Verizon, that company, not only that company, most of the companies, big companies, what they do, they recruit employees from other companies. For example, Verizon recruits from Wipro, from Infosys, from other companies as well. So those employees will work, they will come to Verizon's company and they work there. The company, Verizon company, call them as vendors, or they call it them as contractors. So because those employees are belongs to other company, then the Verizon, uh, they may not feel safe to give access those vendors to access their network. For that reason, the Verizon can create their own network, they separate network for these vendors, so that vendors can work only in that network. That is, they can create their its own VPC, the VPC for, and in this VPC only the vendors can work in that. That way, they using VPC, a company can create a separate virtual data center. In that data center, whatever service created can be given to access to only to the vendors. This way, they can secure their own network. Improved performance. You can prioritize the network traffic of select applications to optimize the performance, helping to eliminate congestion and potential bottlenecks. So your performance also can be improved by using multiple subnets in the VPC. How we'll see that. Virtual private cloud. It is logically isolated from other virtual network inside the AWS cloud. So that means on the cloud we will have multiple virtual private clouds, and each are logically isolated. So each virtual VPC is different, like each different data center. They cannot able to communicate from each other, but there are various other ways to connect to one VPC to other VPC if you want. Max 5 VPC can be created and 200 subnets can be created, okay, in one VPC. So in one VPC you can create 200 subnets, and 5 VPCs you can create on one account. On when you create an account, AWS account, in one account you can create 5 VPCs, 5 logical data centers you can create, and in each VPC you can create up to 200 subnets. So actually 200 subnets are not required. So depending on the product architecture, the architecture will inform us how many subnets are to be created, and basing on that requirement only we create. So mostly we won't create more than 5 to 8 subnets, but it is capable of creating 200 subnets. We can allocate maximum 5 elastic IPs. Okay, so elastic IPs you can allocate up to 5 elastic IPs. Once a VPC is, why elastic IPs topic came here, because we require to create elastic IPs also when you are creating a virtual private cloud. Once a VPC is created, then dynamic host configuration protocol, NACL, we call it in short NACL, network access control list, and security group will be automatically created. You will see that when we do practicals, at the time when we create a VPC, along with a VPC, a DHCP and a NACL and security group will be created automatically. So what is dynamic host configuration protocol? Is a client server protocol that automatically provides an internet protocol IP host with its IP address and other related configuration information such as the subnet mask and default gateway. So everything the DHCP will take care. A network access control list allows or denies specific inbound or outbound traffic at the subnet level. So when you compare NACL with security group, in security group we always used to give inbound rules only. We never touched the outbound rules. Outbound traffic we never touched. I told you, right? When a guest comes to our home, we allow him to come in, but when he wants to go, we can't restrict him. Same thing, security group is like that. But using knackle, you can also put a condition to that guest when he has to go out of the house. That is the meaning of outbound traffic. So you can restrict on outbound traffic as well. And also one more difference between knackle and security group is that security group, in security group, whenever you add an inbound rule, automatically outbound traffic will be allowed. But in knackle, you have to specify both inbound and outbound. And one more difference is that in security group you can allow only allow, but you cannot deny. That option is not available in security group. You only which protocol you want to allow, only that you specify. But which protocol you don't want to allow, you will not specify in under security group. But whereas in knackle, we can specify both. We can allow and you can also mention which protocol you want to deny, that also you can mention. Now, virtual private cloud in continues here. A VPC is confined to an AWS region and does not extend between regions. So one VPC is for one region. Remember, one VPC is for one region, and in the same VPC we will have multiple. It will cover all the availability zones. It will cover all the availability zones. So, for example, if you take Amazon Cloud, if you log in and if you check once here, if you check carefully, if you come down, if you go to the network settings, if you click on edit button, and this is a VPC ID, you just remember the last three digits, uh, three alphanumeric, so that is 1D3, and go to our subnet. And observe here we have VPC, here also we have VPC. For each subnet we have VPC, and if you observe carefully, every VPC is unique, same VPC, 1D3, 1D3, 1D3. That means, what does it mean? These three subnets are in three different zones. It is 1B, it's in 1C, right? It's another zone. So so that means in VPC all zones are included. That you should understand. All zones are included, and everything comes under VPC. That you should understand. Once the VPC is created, you cannot change its CIDR block. What is CIDR block? See, if you come down here, here you have CIDR is a short for classless inter-domain routing. That means till now we have studied about class A, class B, class C. This is classless. Okay, this does not have any class. An IP addressing scheme that replaces the older system based on class A, B, and C. A single IP address can be used to designate many unique IP addresses with CIDR. With using CIDR, with a single IP, you can designate many unique IP addresses. That is the advantage of using CIDR. A CIDR IP address looks like a normal IP address, except that it ends with a slash followed by a number called the IP network prefix. CIDR addresses reduce the size of routing tables and makes more IP addresses available within the organization. So that advantage we get if you use CIDR. Okay. So once a VPC is created, you cannot change CIDR block. So in a CIDR, if you see here, for example, if you go back and if you watch our screen again, this one, where is that? If you observe carefully here, in the VPC, you have in /16. /16 means what? Out of 32 bits, 62 bits are reserved for network ID. That means remaining how many? Only 16 bits are remaining. That means what this VPC is saying is that you can create IP addresses up to how many? 2 to the power of 16. 2 to the power of 16 means how many? 65,531. 65,531 IP addresses you can create. You can create. So once you given this CIDR range, You cannot modify this range. If you want to modify, then you have to delete the VPC. You cannot modify it. That you should understand. If you need to different CIDR size, need to create a new VPC. Okay, the different subnets within a VPC cannot overlap. The different subnets within a VPC cannot overlap. You should understand that. Cannot overlap means what? Suppose there is a range for if you take this CIDR one, this you see. This what is the side? This is subnet. What is the CIDR range for the subnet? Come over here. You see CIDR is /20. Okay, just scroll down. See this CIDR. It is 172.31.16, and see this one, so 172.31.0.0. So if you take this both, it's two different ranges. These are two different ranges. It is O.O ending with O.O, and this is ending with 16.0. So what is the difference? So one is 172.31 O.O, another is 172. So when suppose you and /20 is there, it said side as /20. That means what will be the first IP address? First of all, how many IP addresses can be created? 32 minus 20. That means 12 remaining. That means 12 bits you can use. 2 to the power of 12 bits you can use to create host ID. Okay, we can use. Okay, we can use 2 to the power of 12 bits. Okay, to create IP address host IDs. Okay. Now first IP will be what? First IP will be this one, and second will be what? This one, and third will be this one, like that. So it will continue like that up to the last uh, octet becomes 255. When it becomes 255, then what will happen? The 255 becomes 0 again, and the last third octet becomes 1. The third octet becomes 1 now. So like that it continues till 1.255. I'm sorry, 255. 255. No, that way. Sorry, 1.255. Once it becomes 255, next time what happens immediately? The last, say third octet becomes 2 and this becomes 0. So like that, if you calculate, the total comes to 2 to the power of 12. That means around 4091 IP address you can create. There is one range, and the other subnet starting with this range. So now this will be unique. You see, this will be 6. First will be this one, and other will be 1. Like that, it continues until it continues to 255, and immediately the other one becomes 0, and this will become 17. So you see, if you see carefully, these IP addresses and this range is these two different ranges. Both all are two subnets are unique. Unique. The ranges are different. That from second bit onwards, third bit onwards, the range is becoming different. And if you take the third octet, if you take the third octet, for example, so third octet starting with what? You see 31.32.0. The third octet is different now. That means every subnet will have unique IP addresses. That you should understand. Any confusion here? Let me know. I will clarify. Clarify, no problem. So the different subnets within a VPC cannot overlap. Overlap means IP address should not be same. It should be unique. Every subnet will have unique IP addresses, because end of the day, every IP address falls into the same VPC, same single VPC, right? In a single VPC, even though we have multiple subnets, all all IP addresses belongs to the same VPC, and therefore all IP addresses should be unique. That you should understand. When you create a VPC, you must specify an IPv4 CIDR block for the VPC. Okay, for the VPC, first of all, we have to say how many IP addresses the VPC can contain. So as you saw in our default VPC, we have /16. That means 65,000 531 IP addresses you can create. That means those many servers you can create, and you can assign to each server, you can assign one unique IP address. And what each subnet will can how much, what is the range, how many IP addresses the subnet contains, again that depends on your project. The project in your team will specify that. Create 3 subnets, they will say 3 subnets. In each subnet we want some 50 servers or 100 servers. So basing on that only we will create the shader. The allowed block size is between /16 to /28 net mask. Remember, you must remember that whenever you're creating a shader, the range should be only falls in between 16 to 28. If you cannot use /15, less than 16 you can't use, and more than 28 you can't use. That you should understand. /28 means what is the meaning of that? 32 minus 28, that is 4. Okay, 4. Yeah, to the power of 4 means how many? 16, right? So minimum 16 IP address you can create in a subnet. Minimum 16 you can create, 16 IP addresses you can create. That means 16 out of 16, 5 are reserved already. So only 11 IP address you can use. That means minimum 11 IP address you can create in each subnet, and each 11 servers you can create. That is the meaning of /28. Minimum, that is the meaning. And maximum, how can you create? How many you can create? /16. So a virtual private cloud contains these components. Whenever you're creating a VPC, so you should understand these are the components goes inside a VPC. Till now we have created EC2 instance. So when in EC2 instance, what component added by default? It comes with volume by default, right? It comes with volume, it comes with CPU, it comes with RAM. Okay, so so with EC2 it's like that. In VPC we have different components. So with VPC we get CIDR and IP address for the subnets. We get implied router. We get routing table. We get internet gateway, network address, translation gateway. Will have what is this? We'll understand coming session. Coming session, each one will understand. And security groups we already know, and NACLs also we have just familiarized. That also we understand in coming sessions, coming slides. And elastic IP, you know elastic, what is elastic IP is. In our last session we learned about it as well. So now comes to subnet. So what is a subnet? Public subnet. First of all, it's a public subnet. We have private subnet. Both subnets we have. So what is the difference then? If a subnet's traffic is routed to an internet gateway, so internet gateway is a service again, one more service, then such subnet is known as public subnet. That means if any subnet having internet gateway added connected to that subnet, then that subnet can be called as public subnet. Why? If you want to, if you want your instance in a public subnet to communicate with the internet over IPv4, it must have IPv4 address or elastic IP address. Okay, so when a subnet, for example, Amazon.in is a website. It is an application actually, right? That application will be running inside the public subnet only. Why? Why? Because that server in which in the server where this application is running, that application you want to access, right? Then that application should have a public IP address. Only then, whenever you say Amazon.in, then automatically you will be allowed to connect to that server because it is inside the public subnet. Because the public subnet having an internet gateway, so internet gateway allowed that application to respond you back. And if the subnet does not have internet gateway, then you cannot connect to it, or nor it will respond you. So if a subnet does not have a route to the internet gateway, then the subnet is known as private subnet, just opposite of public subnet. So you should understand the first 4 and the last IP address of subnet cannot be assigned or used. You should remember this. So we have this. So if you take any range, first one starts with 10.0.0, that is network address. The other one is reserved for by AWS for the VPC router, and third one reserved for AWS for the DNS server, and the fourth one is reserved for future use, and the last one is called as broadcast address. That is also reserved. AWS does not support broadcast in VPC, but reserves this address. You should understand broadcast address you cannot use, but it is available and it is reserved. So these 5 always you should remember, even though you get 2 to the power of 4 it means 16 out of 16 IP address 5 are reserved, so only 11 you can use. That's the meaning of not using meaning of reserving of 5 IP addresses. Always you have to subtract these 5 IP addresses. Whenever you get a range, you have to always subtract 5 IP addresses. And in virtual private cloud we have two types. One is default VPC, another is custom VPC. So till now we have used VPC, that is default VPC. But in real time, we never use default VPC. We always create our own custom VPC. And when you join in a company, most 90% a custom VPC already created for you, and you just have to use it. That's all. But if the company is starting a new project from scratch, only then you have to start from creating the custom VPC. Otherwise, most of the time, a custom VPC will be already created for you. So first of all, let's understand what is default VPC, how it looks like. Default VPC created in each AWS region when an AWS account is created. That means whenever your AWS account is created, for Mumbai region, a default VPC is created. For Sydney region, for Singapore region, for Japan region, you take any region, you name it. For every region, AWS Cloud will create a default VPC. What is default VPC contains? It has default CIDR, a range is given, that is /16. We just saw right, VPC in the VPC address we saw /16. Security group will be created, default security group you saw that, default knuckle will be there, and default route table also will be there, and internet gateway also be there by default. That means that is the reason till now we used to deploy web applications inside our Linux machines, Windows machines, and we used to add HTTP protocol, and after that we used to access those applications through the browser. How it is possible? Because the VPC by default, the subnet is by default connected to internet gateway. That is the reason we are allowed to connect to the internet. Let's see this in more detail. Let's understand. So this is a default VPC, default virtual private cloud. These are AWS cloud. In this cloud, this is a VPC. So this VPC covers all the regions. For all the regions, is only one VPC. Here in this picture, no space, only two zones I am showing you, zone A, zone B. And as discussed, this is one subnet, this is another subnet. So subnets can be any number, no problem. As we discussed, in each VPC, in each subnet, uh, uh, in each VPC, we can create up to 200 subnets. In each VPC, you can create up to 200 subnets. So it doesn't mean that in each single zone we should have only one subnet. It's not like that. You can single zone, you can have multiple subnets. And when you observe carefully, here you see a table on the right side. This is called a route table, or more specifically, you can call it as main route table. You can have multiple route tables. You can have multiple route tables, but for the default VPC, we always get only one route table. In the one route table, if you see the entries carefully, it is saying it is a range, it is a CIDR value of the VPC. This is a VPC, default VPC, and the same value here we have here in the table. And the target column, it is saying local, meaning what? That means all the subnets, whatever servers inside the subnets, all can communicate among them using the private IP address. So the private IP address is used only to communicate among them. So we are saying local. When you say local means what? And a range also be giving here /16. That means, suppose, assume you have created 65,000 IP address, 65,000 servers you have created. Assume all those 65,000 servers can communicate among them whenever required using their allotted private IP address. Using the private IP address, they can communicate with each other. That is the use of private IP. If you see, whenever you create an instance, every instance will contain a private IP and a public IP. This also on private IP and public IP, right? That is a private IP. Why? Why? Because this instance can communicate with this instance using the private IP. Similarly, why the public IP? This public IP, you can, using the public IP from the internet, we can connect to this instance as well as to this instance. So for that, public IP is required. Okay. Now, suppose when this instance want to connect to the internet, then whenever it want to give a response to the customer consumer from the to the which is using the browser, when the response going from the instance, the router is a virtual router. It will do what? It will check the table. It will check the table, and it sees, verifies whether in the table internet gateway added or not. So internet gateway is a service we discussed just now. Internet gateway has to be added. If it is added, only then we can connect to the internet. At your home also we have router, right? We have router. So the router, without the router, you cannot connect to the connect we cannot connect to the internet, because at our home our laptop will have private IP address. We will not have public IP address. We will not have a public IP address. But to communicate with the any website, in the internet, if you want to communicate, you have to communicate with a public IP address only. That is the reason your router will create you a temporary public IP. It automatically it will create a public IP for that session. So that public IP once created, then using that public IP, you can we can communicate with the internet. Similarly, here also the EC2 instance, whenever it wants to communicate with the to the internet, first of all router checks whether the internet it can communicate with the internet or not. The entry it checks. If entry is there, it is entry internet gateway ID. So by default we have a table in that internet gateway ID will be added in the default virtual private cloud. But when you creating a when you are creating custom virtual private cloud, then you have to create everything manually. Internet gateway also you have to create, and you have to add it manually. But in default virtual private cloud, a entry will be added automatically. Entry will be added automatically to this main route table. So when router finds that entry, then it will allow the request to the internet gateway, and internet gateway will allow to connect the EC2 instance to the internet. Similarly, the same with the other subnet. This also, if whenever it want to connect to the internet, the request first goes to the router. A router verifies whether it can connect to the internet or not. It will check the internet gateway entry. If it is available, only then the router will forward the request to the internet gateway. And if you observe carefully here, the subnet here, default subnet 1, default subnet 2, each having their own CIDR values, /20/20 with unique IP range. Okay, IP range is different. 31.0.0 here, 31.16.0. The difference you should understand first of all, very important. The third octant having 0, here the third octant having 16. That is very important. You should understand. Importance of that you should understand. Please let me know if you have any questions here. Now comes to our virtual private cloud, that is custom VPC. The custom VPC is a VPC an AWS account owner creates. We have to create. A AWS user creating the custom VPC can decide the CIDR. So while we creating the CIDR, we have to decide what is the range we have to give. That we can decide. And before we go to custom VPC, okay, first of all, let's see whether this main route table available or not, internet gateway is available or not, okay, subnets are available or not. These things we will understand first, where we can see them. Okay, let's go to our instance. So here type VPC. Here we have VPC. Click on it, VPC. This is a VPC dashboard. You see carefully. Here is VPC. How many we have? 1. So see all regions. If you can see all, for all the regions you have VPCs. One NAT gateway. What is NAT gateway? NAT gateway is not there. So when you creating a custom VPC, which we may require to create a NAT gateway. We'll see. How many subnets are there? 3 subnets are there. Route tables how many? 1 route table. Okay, the same thing what we discussed here. 1 route table, yes, we have 1 route table. 1 internet gateway, yes, 1 internet gateway. DHCP is created by default. On security group will be created default. NACL is created by default 1. Okay, now let's go to your VPC. Click on your VPC on the left side. This is your VPC ID, and click on the left side again subnets. These are 3 subnets. These 3 subnets belongs to this VPC ID, this VPC, and observe carefully. Each subnet can have how many IP addresses? 4091, 4091, 4091. Now go to route table. This is a route table. Select it one. This is a route table and come down. Click on routes. You see this is the internet gateway ID, and this is the VPC CIDR, and it is local. That means all the instances can communicate using the private IP, and this is the, what do you call this one? This is your network ID. I'm sorry, this is your internet gateway ID. So where I can see network ID, you see then this ending with 27827D. Click on the left side internet gateway. You see 27D. It is attached, right? It is attached to which VPC? To the default VPC. So this way we can find all these components. Now let's go to custom VPC. Is a VPC an AWS account owner creates. AWS user creating the custom VPC can decide the CIDR. Has its own default security group, NACL and route tables. When you create a VPC, automatically a security group and NACL and route table are created. One route table is created by default. That is the main route table. So these two things, security group and NACL, you don't need to create separately. And even the route table does not have, and here one route table only created. If you require more route tables, you have to create manually. Does not have an internet gateway by default. One needs to be created if needed. So internet gateway will not be created by default, whereas in default VPC it is created. So we have to create ourselves the internet gateway. How it looks like, if you see this carefully, this is a VPC. There are two different subnets, and assume in this example, assume this is there are three servers, web servers, and each server contains Amazon application running. So three servers having the same application running, and these are the three servers which contains data. These are the database servers. So for all your products, the products information is stored in the database. So three replicas are running. Each database having the same data, but three are running. So whenever this web server want details about a product, it will communicate with this with the database server using the private IP address. This way we can isolate our databases in a private subnet. Why I am saying it is a private subnet? If you observe carefully, we have only private IP addresses. There are no public IP address. You see, but if you see here carefully, we have elastic IPs. In real time, we won't use public IPs. We use elastic public IPs. Elastic IPs are nothing but public IPs only, but elastic. They will not change. That means when you start and stop, as you know, public IPs will change. That is the reason we always use real time. We always use elastic IPs. And if you observe carefully, these three elastic, every server will have a public IP and a private IP. But here if you observe this database, it does not contain any public IP. That is the reason it is called as a private subnet and the public subnet. And this, because this is a private subnet and it does not contain a private public IP address, because of that reason, nobody can connect from the internet to this database. Nobody can connect to it. And if you observe carefully, we have two tables now. Two tables. One is main, one is custom route table. Forget about main table and custom table for time being. But as of now, understand that we have two tables and two route tables, and each if you observe carefully, the custom, this one above you see, it is very similar. It's like our default VPC. It's having similar. It contains internet gateway. So this is a public subnet. It is connected to this custom route table, and all the servers inside this can communicate with the internet, and from the browser, public can anybody can connect to our internet. Two-way communication will happen because this table having entry of internet gateway. Internet gateway will allow that. But this private subnet, if you see, for this, the same VPC range is there. It's again local. This entry will be same for both the tables. The only difference is that this route table contains a different ID, that is NAT gateway, network address translation gateway. What is that? That we try to understand in a moment. So here you see it is a network gateway, but if you see observe carefully, it is in the public subnet, but entry is in this table. This entry is not here, but the entry is here. It's somewhat confusing, right? So actually, why it is the rule is that the cloud rule is that at AWS cloud rule is that whenever you want to use a NAT gateway, first of all, why we require to use it, I will explain in a moment. But whenever you want to use a NAT gateway, that NAT gateway should be available in the public subnet only, even though it is required by the private subnet servers, but still the NAT gateway should be inside the public subnet. In interview they will ask you where you will create the NAT gateway, in the public subnet or private subnet. Always remember, the NAT gateway always created in the public subnet. And next, why it is required? See, for example, database, here the database can be any it's also a software, right? It is also software, is SQL server database or Oracle database, MySQL database, it could be any database, right? So every databases also have to update. So they have to update now and then whenever the software companies want to releases some fixes, some updates to the softwares. So by that, what happens, the database servers, whatever we are using, the softwares whatever using in the servers deployed, whatever softwares we are deployed in the database servers, those softwares has to be updated, like your WhatsApp also. I'm sorry, not your WhatsApp, your applications inside your mobile also, you have to update. You will get regularly updates for all the applications you are installed on your mobile. So you always go to the Google store and you will update your applications, whatever you are using in your mobile application. Similarly, every uh, every software needs updates. So database also contain some softwares. These softwares we call as database softwares. So whenever you want to connect, at that time we want to connect to the internet only to update. So this is one way communication, that means only updates can be happen, but from the internet nobody can connect to it. So using internet gateway, it is two-way communication, but using NAT gateway, it will not allow others to connect to the database. It only for the purpose of updating the software, that's all. So for that reason, temporarily, even though it's in the private subnet, but temporarily to update itself, it has to connect to the internet for some time. For that reason, what we have to do is, we should not use internet gateway, we should use NAT gateway, network address translation gateway. We have to use it is server. So one, you have to create that in the public subnet, and in the main route table or custom route table. It could be any route table. Route table, main or custom is not mandatory here. That is, don't worry about that. But which subnet connected to which subnet, which table, that is important. Okay, here the entry of the NAT get table should be added whenever this database want to update itself. Then the entry should be added here. NAT gateway entry should be added here. Why? Because now this software inside the database want to update itself. Then a request, it will send it to the router. Router will check the table. It will check, okay, it's a public subnet, private subnet, does it have NAT gateway entry? If it is having, then the request goes to the internet. The request will pass to the internet. Okay, that way NAT gateway will be used by the private subnet. So whenever you want to provide any internet connectivity for the private subnet, then only you will create the NAT gateway. Otherwise, NAT gateway we will not use. That you should understand. And remember, whenever you create a NAT gateway, the NAT gateway must be assigned a elastic IP. It requires a elastic IP. So we have to create elastic IP, and then we have to assign that elastic IP to the NAT gateway. In this picture, if you have any question about any component, let me know, because this everything we are going to do practically. So it is better to understand each and every component. And moreover, in coming slides, I will be explaining in more deeply about NAT gateway, internet gateway, router, route tables, everything in detail. I'm going to explain. But still, if you have any questions, let me know. Now, implant router or router and route table, what are those? It is the central routing function. It is a central routing function. It connects the different availability zones together and connects the VPC to the internet gateway. Okay, router is what? This router, it connects to multiple zones. It connects multiple ability zones and connects the complete VPC to the internet gateway. That is the use of router. You can have up to 200 route tables per VPC. So per VPC like this, you can have 200 route tables, and each route table can have, here two entries are there, right? We can have up to 50 entries in each route table. Okay, so each you can have up to 50 route entries per route table. Each subnet must be associated with only one route table at any given time. Okay, every subnet must be associated with only one route table. That means this router, if you see the previous public subnet, two route tables associated with one route table, it is okay. But like here, it is associating with route table, it should not associate again to with this route table. Okay, any number of subnets can associate with one single route table. Once they are associated with one route table, they should not associate with another route table. That is a interview question you should understand. If each route table, subnet, okay, if you do not specify a subnet to a route table association, the subnet will be associated with the default VPC route table. That means what? So suppose here this private subnet, you are not suppose you forgot to associate this subnet, private subnet, to a route table, then automatically this will be connected to your default route table. The default route table, which coming with the default VPC. Through this, it will be that private subnet will connect to this public route table by default. So that is the reason, if you forget, but still, if even though you forget, that subnet will be automatically attached to that public route table. So that's the meaning of this line. If you do not specify a route subnet to a route table association, the subnet will be associated with the default VPC route table. You can also edit the main route table if you need, but you cannot delete main route table. So again, this is also another interview question. So they may ask you, can you delete the main route table? No, you can edit the main route table, but you cannot delete main route table. But if you still want to delete, how can you delete? However, you can make a custom route table manually and make it the main route table. You can make it as a main route table. Okay, create another route table and make it main route table, and then delete the former main route table as it no longer a main route table. If you want, you create another route table and make it a main route table and delete the previous main route table. That way you can do it. But at all the time, one main route table should be there. You can associate multiple subnets with the same route table. Okay, you can associate multiple subnets with the same route table that we already saw. What is internet gateway? An internet gateway is a virtual router that connects a VPC to the internet. Default VPC is already attached with an internet gateway. If you create a new VPC, then you must attach the internet gateway in order to access the internet. Ensure that your subnet's route table points to the internet gateway. Okay, it performs NAT between your private and public address. Okay, that means NAT means network address translation. At your home we have private IP address only. So whenever you want to connect to the internet, we should have a public IP. Actually, that job is done by the network address translation. Even the router device which you are using at your homes, it works as a NAT gateway. Okay, it translates and gives us a public IP. You are connecting through our private IP, but you are connecting to the internet means actually we don't have public IP, but still it automatically converts that private IP and it gives a new public IP so that you can access the internet. It supports both IPv4 and IPv6. IPv6 we use mostly in our mobile devices, right? And network address translation. So these topics will connect tomorrow. I will stop here.